Welcome everybody. Thank you, like Frederick said, thank you to being there at the afternoon of the closing session. So today I will describe you what Eclipse SensiNact is and how we added support for the OGC SensorThings standard. Does anybody know here either one of them, SensiNact or SensorThings? Two, okay. Half of the session. So, I'm Thomas Calmant. I'm working at Kentyou, which is a small company in France, and which is an Eclipse SensiNact supporter and a member of the Eclipse Foundation. Myself, I'm a software architect there, also an Eclipse committer because I work on Eclipse SensiNact. So, the idea is to get data from your city and push it to the cloud and to make your city smarter. So first we have to start from the ground up, from the sensors. Obviously, sensors are coming in many ways with many protocols. We saw Spark Plug in the previous talk. We don't support it for now, but we could add that as we will see in the rest of this presentation. So we start with sensors and we move to SensiNact. SensiNact, in fact, will supports and will support a lot of what we call softband providers, which means a way to access data from sensors in various protocols. It abstracts internally what data is, and it provides it to the outside world with various protocols also. And in our company, we use it that way. We get a lot of data from various categories of data and sensors in various ways, various protocols, more or less abstract. We put them in Kentyou Data Hub, which is in fact an Eclipse SensiNact version with more providers. And we put that in the cloud and do some analytics, and we make your city smarter with that. So, start with Eclipse SensiNact. Eclipse SensiNact is 10 years old, in fact, this year. It started at CEA, which is a French institute, French research institute. And the idea there was to manipulate IoT devices using various protocols and to modelize their content as a uniformed way. It was developed so there. After some time, the project was pushed to the Eclipse Foundation. Kentyou was created to continue the development afterwards, and finally we now have two new contributors, the city of Vienna and a company based there, Data in Motion. So what's the model behind SensiNact? In fact, it's simple. We have a service provider, which is often the device that provides everything. So on that device, we can add, for example, a presence sensor, a wind sensor, a temperature sensor, whatever you want. But it can also represent a virtual device to get data from, for example, we have afterwards the list of buses in New York, which comes from a GTFS real-time data and gives us a position of every bus, their speed, etc., which is a virtual provider in that case. In services, we have a standard one that all providers have. It's the admin service, which is there to describe the provider, so its name and, more importantly, its location. Then you have a list of services, and that part is really dependent on how you want to model your data. So here it's the basics example. We have a sensor with both two resources, temperature and humidity. But you could decide to split, in fact, a service that gives you temperatures and to do statistics, the average for the last hour, maximum, minimum, etc., etc. It really depends on how you want to model your application, but it's always in the same trilogy: a service provider, a service, and a resource. Above that, we use EMF, so Eclipse Modeling Framework. So it can be frightening for some people, but don't worry, it's not mandatory. In fact, it's what we use internally. And if you don't give us a model, we will generate one according to the data you put in. But if you give it at the start, when you register the provider, we are able to use that model to ensure that the data is in the right types and that it follows a set of constraints. You can also say that what you give us is a minimal version of the model that can be extended if we detect a new resource, or if it's fixed and nothing else should exist. Like I said, SensiNact works with a set of providers. So we have the northbound providers where people access the data from inside SensiNact, and the southbound providers is how SensiNact accesses data from the outside world. At first, we have a set of bridges, like we call them, but we are working with OGI, which allows us to extend the number of bridges, even in runtime, and even to update them independently at runtime, which is really important for a city to be able to fix some bugs while the rest of the data keeps coming in. The basic distribution of SensiNact comes with a REST and WebSocket northbound providers, and the southbound providers are HTTP polling, callback, or MQTT, pub/sub. The access to SensiNact comes with a set of verbs. So we have a different kind of them. The description, which just says what is your provider, your service, and your resource, what it contains, etc. Note that a resource can be either a data resource, which will hold, for example, a temperature, but it can also be an action. So, for example, if you have an electromagnet, you can shut it down and open a door, for example. You have then get, which is obvious, you get the data. You have set, act, and subscribe, unsubscribe. So the usual verbs you will find in any IoT providers. So in get and set, we return values and types. That's something very important in SensiNact. We really care about the type of data that is held by a resource. On the subscribe, the important feature is a filter. Either you listen to a single resource and you see how it evolves in time, or you can say, I want to get anything that follows, that matches the given filter. So that filter can be either on a value or on a location, for example. Here is just the full REST API we have in SensiNact. The idea was to keep something really simple. So as you see, it's really just a simple hierarchy. You go deeper and deeper into the resource in the model, and we just use a get and post there. You cannot delete a provider from the outside. It's really something that must be inside the core. So in the Java API of SensiNact, doing it from outside didn't seem useful for us. One important note is about history. At first, and in fact it's I think a good idea, SensiNact doesn't keep track of history. It just digital twin, it keeps the current state of everything. If you want history, in fact you create a southbound provider. It will interact with the database, so it's a virtual provider. It contains a lot of actions, resources, so you call them as functions. And it looks at the internal events of SensiNact to be notified of the new values of each resource. So it stores them like that, and you carry them as a single query to resource there. You had a question, James? Or? Okay. Don't hesitate to interrupt me if you have questions. As always, we see here the small plus, so we can add have, using that structure, in fact, you can have multiple history providers to fit your needs. We publish a basic one with SensiNact, which is in the open source project on GitHub. But Kentyou provides also more advanced history providers, which allows to have a lot more filtering, both in the storage data and in the complexity of queries you can execute. So, the subject of this talk. So SensiNact is a platform that is used by many cities. And one of them, the city of Vienna, asked us one day to see what we could do with that OGC SensorThings API standard. So that standard is from the Open Geospatial Consortium, so that's what the OGC stands for. It's not that old, but it starts to become a bit. So it dates from 2016, and the version that is currently pushed by different projects from the Horizon Europe set of EU projects is the 1.1 from 2020. So the idea is, as always, to manage data from IoT devices. First time I heard about it, I thought at this picture a lot. So the city of Vienna had two solutions. Either throw away everything they have with Eclipse SensiNact that they use from some time, or they asked us if we could extend SensiNact to just provide a new northbound provider to match the expectations of the Horizon project. So, the first thing we had to do was to understand what was the data model of OGC SensorThings and how to adapt what does it look like in SensiNact to match their requirements. So the first thing is a thing in OGC SensorThings. So it's anything that has a locations and publishes data streams. That's the definition. So that matches our provider. It holds a lot of resources, which are data streams here, and it has a location. We saw the admin location resource before. That's how it's supposed to be called from the OGC SensorThings REST API, which is the main standard, and we return that. I will show you the other JSON, but we just stay on that one, just to see one thing. So in fact, how OGC SensorThings encode data, you have a set of keys, so it's a JSON first. You have a set of keys that are defined by the standard for each kind of item you are looking for. Then you have IoT ID that ensures you know in OGC naming what you are currently looking at. A self-link that is supposed to be a link to the current REST URL. And then you have links, navigation links to the linked data. So for example, here I have a thing. I know it has data streams. That's how I will access them. Historical locations and locations. We will go deeper into those right after. So that's what it looks like. And here, so getting a thing will just give you a name, description, and links. A location, same thing. We know, so that's a type defined by OGC SensorThings, and it must return the current location of a thing. So for us, the current location of a provider. So it was a no-brainer. We just accept their current format. We return a name, description, and the location of our item. And each time you have an ID, and you have also navigation links to go back to the other levels. For example, from a thing you can go to a location, to its location you can go back to the thing via those navigation links. You then have historical location, so that's the one that required the SensiNact history. So here you must be able to go back in time and say, I want all the locations of a thing, for example, a tramway, a bus, something like that. And you have to find a way to store them and to access them. In the standard, in fact, the IDs given here are not at all specified. It's just an ID. I suppose they don't even indicate that it must not contain an end parenthesis. But that allowed us to create just that kind of format. We use a provider name and the hexadecimal timestamp in second, which is sufficient for the data we want. And so you carry the locations of that provider, and here is, for example, right now or 10 minutes ago, precise to the second. Again, when that's for listing historical locations, you never use that directly. That's a navigation link because what you will ask is the historical location of a thing, and then you will access that URL. You will know what timestamp to put there. Then you have the data streams, which are in fact resources for us. We just have a set of values coming in and out. So here you have the unit of measurement, which is based on the unit of measurement RDF nomenclature, ontology, sorry, I was looking for the name. You have the properties that are defined inside SensiNact, if you need them, and you have the timestamp there. But that's the description of the resource, not the value. Then you have the sensor, which is exactly the same thing. It's just a way in SensorThings to say a sensor can have multiple data streams, but the data streams is only one thing, one set of one phenomenon. In fact, the term used in the specification. We then have the observed property, which is again a meta description of a resource for us, and an observation, finally, which is the either current or historical version value of a resource. So here we use again the timestamp to know the last update, which is the current value of a resource. But you can also go back in time and take the resource that was there a week ago. Again, you never go there directly. You have to go through either the thing or the data streams to access that URL. Last thing here is a feature of interest, which is a bit of anything you want. It's something associated to your sensor. So there is no explicit definition on what it should be. From the SensorThings API specification, it's just a hint that it should return a feature, a GeoJSON feature that indicates where the thing was during your observations. So it again matches our admin location resource from the SensiNact provider. Nearly there for this specification. One trick is that for each REST URL I showed you, you have a query option that is indicated here that allows you to, if you have a large number of observations, for example, you can do pagination with order by top and skip. You can also just count the number of observations you had, and you can also have a filter to return only matching values. The filter was the trickiest part for us because it's a specific filter defined in the Open Data Protocol, or OData for short. So it has some operators, some paths, depending on where you are, depending on the context you have here. And finally, it has some methods, especially geospatial methods, which is logical for OGC protocol. So here, for example, we want all things which have a location that was less than a meter away from that point. So we had to implement both a parser for that language plus, so I think it's 40 methods of comparison. You have geographic distances, you have also time references, this kind of stuff. So in fact, we decided to move it the lowest level possible in SensiNact, which means obviously we converted the grammar that is given in a format and we want it in Antelar. And in fact, we converted that in an high criterion object for SensiNact. An high criterion is something you give to the core of SensiNact. It will go through all providers, apply it, and return you all the providers and resources that matches that. What you want. The idea is to have the minimal snapshot of everything in memory. You give that to the OGC SensorThings provider, and it can do its manipulation to return something that matches what OGC wants. So, adding OGC SensorThings, everything that you saw there was developed in 4 bundles, 4 OGI bundles. We have the REST API, which is just using the Jakarta RESTful Web Service whiteboard specification of OGI. So, to be short, it's just a Java interface, which gives all the URLs you saw before, all the possible interaction there, all the navigation links that could be, and they were defined, like I said, in a set of Java interfaces in a specific bundle. Then you have the DTOs, so the data transfer objects. So all the JSON I showed you before was described here as pure Java objects. Then you have the filter, which is the biggest bundle we have here, that does all the conversion, parsing, and execution of filters. And finally, the REST gateway, which is where the implementation rests. So we have 4 bundles. In total, we have less than 1,000 lines in total. Then you put that into SensiNact. So in fact, what we do is we create an OGI feature file, which in fact describes the number of bundles you require for your feature. Here it was quite simple. We have our 4 bundles plus so the DTO, the REST API, REST gateway filter, we included, to make sure it's there, the filter engine of SensiNact, some dependencies, and some other dependencies here. So here just for the parser, the geospatial filter functions, and here is a conversion from Java objects to JSON. You put that in SensiNact, and in fact it will start what you want. So the feature file corresponds to how to start that. We have core features that start the HTTP, MQTT, and history providers on the softbound part. So here, for example, we get information for transport materials, like the tramways, for example. MQTT is more for small sensors like temperature, etc. And when you use your browser to access the OGC SensorThings API, you have your main entry point that gives you the addresses of everything in OGC, all the navigation links, and it works as expected. But what about notifications? Because OGC SensorThings API, the basic one, is all about polling and describing. So the SensorThings API was extended to an MQTT in there. So you just subscribe to a specific topic, and when you have an observation that comes in, you notify the observer. The obvious thing to do. The only thing is that the query options are inside the topic, which means that if someone wants to select just 1 or 2 fields in the result JSON, it gives that information in the topic. So we cannot do the simple thing, sending data to that topic and just let the broker work with that. The solution we had was to use an internal MQTT broker so that we can listen to subscriptions and decide what to return to the client at that time. Again, we use that So here it's a select, so it's in the final result, but it can be a filter. So what we do is internally we keep track of all the subscriptions and the least important filter. So the ones that will, so for example, if we have two filters that work on the same resource, we will get all the values of said resource and choose if we send it or not to the client. If you have one listener with a specific filter, we apply that filter to make sure we don't send notifications for nothing. Also, why is that important? Because internally, SensiNact uses OGC type-safe events. So when something happens, for example, a resource changes value, it is sent in an event bus, which is typed. So internally, it's great to make sure that we work with the right type of data. But also, if there is no listener there, the event bus will ignore the message. So it avoids some operations, which is quite great when you run on low power devices. Just a bit of the code we have there, but nothing fancy. One important thing is that we reject everything that is not a non-path. So we reject the wildcards and path placeholders in MQTT. So for example, if we go back here, we reject people that say we want anything that has observation. We want a full path to be valid so that we can work with optimizations. Okay, just for those who want to see some code. So here you have the final distribution we sent to Jena, which is just an MQTT, an HTTP MQTT, and a history softbound providers, an OGC SensorThings REST API, and the MQTT extension. And it works. So this was released, and it's now part of the open data catalog of Jena. You can access directly the OGC SensorThings API, or you can access a web client to see the data live, which look like that. I have it somewhere. No. So that's ours. And this. Okay, so here, for example, we have various sensors with their current value in Jena. And everything is accessible via OGC SensorThings, and the UI keeps you accessible the data we saw in the JSON files. So everything there is currently live. So you can see, as I explained, we have the data stream here. We have the name of the provider, which is the identifier of the sensor in the city. And like I said, they shows to have services to have the what is measured, the observed property. So here a pressure, for example. And in resource, they have here the average. They also have the maximum, minimum, etc. Available. Another UI that we have internally is that one. So here we are in New York, and that's what I explained. With the same northbound providers and just a new softbound providers this time, we have the live position of buses buses only in New York. Tramways are and metro are taking a part. So here it is. Oh, didn't work. Yeah. So what's next? Currently, we are working on adding new softbound providers. So the most important one, the most urgent one, let's say, is LoRaWAN. We also have a project that will use the Matter protocol with threads. I'm not yet, I'm still not fully aware of that one, and I'll work also on adding the Z-Wave protocol back, because one important thing to know is that SensiNact is quite old. We saw it; it's a 10 years old project, and last year we did a full rewrite of its internals to match the latest specification of OGI, use the latest tools available, and also we moved from a Java 8 code base to a Java 17, which allowed a lot of optimization, and we are not done yet on that part. So we have to bring back a lot of protocols from the old providers to the new ones, because we changed a bit the APIs, especially the way events are handled internally, which makes it faster. And strangely enough, it makes it run in lower devices than it was able before. For example, we managed to run it on a Raspberry Pi 1, so there's a really small one with a few cores and a very few amount of RAM. It doesn't handle 1,000 of sensors, but it's already there. The advantage of that in a structure is that now, as we will convert LoRaWAN data into an internal model, in fact, the northbound providers don't have to be updated to provide those data. So there is absolutely no work to add to make sure that, for example, if we add a traffic light sensor protocol, there is no work to do on the OGC SensorThings northbound provider to see those data. So that was the presentation. I don't know how long it took because I don't have the time there. I invite you to look at the doc. We rewrote it, so now it has a quick start guide, so newcomers can use it quite easily. So you can find it on read the docs, and you can find us at kentyou.com. Thank you. Any questions?
Thank you for a very interesting talk. I'm from Metrology Institute in Germany, and as an example, there was a network for Jena. How many sensors is in that network? I'm just curious.
I don't have the numbers exactly.
The order of magnitude.
I remember that Stefan from Jena City told us that I think there is about 50 sensors per tramway.
Okay.
So that gives an idea. They do all traffic lights, and they have some sensors in the outside with the pressure, temperature, humidity, wind, and I'm missing one. I don't remember.
Anyway, they are electronic devices, sensors that need to be calibrated and certified. How is it done?
I think it depends on their provider of data. In fact, what they do is that they buy electronic equipments, which is already calibrated, and we just connect to them from one way or another, depending on their protocol.
That means that once a sensor is set in the network, in its location, that there is no flow of data in your network on calibration, or
on calibration, no. We have
confirmation of performance, let's say, because there are two different processes. Calibration is one thing, and confirmation of performance is another thing, which has to be done, especially for autonomous systems which are running in real time.
Yeah. So for that, so it's not inside SensiNact, it's more in what we do at Kentyou. We have a part which is more AI analytics, which is trying to find also how to say that, erroneous values. We had an example in the city of Santander where we had, for example, temperature sensors that were in an area of a neighborhood, let's say 1 or 2 blocks, and there we always had well, after some time, we had a temperature sensor that was beginning to have a lower temperature than the others and drifting from the others. but that's more an analytic part. So we reuse the notifications from SensiNact and its historical data to check if it's usable or not.
Okay, thank you.
Want more information about the ENS situation? From ENS should be around.
Well, yeah, the guy from yeah. Other questions? No? Okay. Thank you for coming this late, and I hope you'll use SensiNact for some trials.